Hello everybody, this is Mr. Steele. It's leap day and I'm at home because baseball practice was canceled due to rain. So in fact I decided to try to get ahead on these things and try to help you out a little bit by providing a few more standard quiz tutorial videos, particularly to help my two Algebra 2 classes in Term 4 coming up next week. So anyway, I decided to just go back and go ahead and start with standard number 1, the absolute value inequalities. This one's been pretty good this term out of all the, most of the standards. This has by far been one of the better ones. But at the same time it's good to kind of go through a review and kind of talk about all the important stuff involved here. So remember, what we have here is basically an inequality, and the instructions don't say solve, they actually just say graph. Like, our solution is going to be represented not as a compound inequality, like that'll just be our work, but actually as a graph. So our goal is to transform that thing over here and turn it into a graph, two-dimensional graph representing the solutions, that all the different points and all the different x values that could possibly solve this inequality, because you won't just get one solution in inequality, you'll get a whole set of numbers in most cases. So really the key thing here, or the process we're going to follow, is we're just going to start by kind of pretending it's just an absolute value inequality. We're going to work to try to isolate the absolute value part. So first, that's kind of our first step. Like, a key fact is kind of our plan is we need to get the absolute value alone. So I'll put it in that way. You can see, of course, it's called absolute value. It means that it makes whatever comes out of it positive. And so from here, like, the algebra to do that isn't actually that difficult in this first problem. We'll add 4 to both sides, make a 0. We'll get 3 absolute value of x minus 5 is less than or equal to 21. And then second, we'll divide by 3. Now, some people like to wait on stuff like this and try to hold off on doing the algebra, but in fact, you won't get the answer right if you do that. So in fact, just start by getting it alone. So we just have absolute value in something. Because our second step in the process that I recommend using, although there are other ways, is to actually use the definition of absolute value. And particularly, that comes from the fact that if you're trying to solve this equation, let's say absolute value of x equals a number, then your two solutions are either going to come from the equation x equals the number itself, or negative x equals the number. Like, that's basically where we're coming from, because the reason is, if the inside is positive, then the absolute value stays positive. It just keeps it positive. If the inside is negative, though, we have to multiply by -1 in order to make that inside argument equal to a positive number. And so that's actually exactly what we do from here. We split it up into two inequalities. One of them, just the regular version, that tells us, or that gives us the possibility that the inside is positive, and one that's multiplied by -1, so that we get the possibility that the inside could be negative. So here it's pretty straightforward. We're just going to we'll do the positive one first. So assuming that the inside is positive, we would have that the absolute value of x minus 5 is less than or equal to 7. The second one, using the definition, is that the inside part multiplied by negative could be less than or equal to 7. And again, that's just using the definition of absolute value. Absolute value means either the positive or the negative version. Well, from here we just have two inequalities to solve, neither one particularly difficult. On this first one, or on the second one over here, just because that's going to involve a little more steps, we'll have to distribute first. We'll have negative x plus 5 is less than or equal to 7, whereas over here we just have x minus 5 is less than or equal to 7. And then for each we just solve them. The steps will be similar. We'll have similar kinds of steps, but one of them, particularly this one's going to be a little harder. So on the left side, we'll just do this guy. So I'm going to get that x is less than or equal to 12, and that's good. That's actually going to give me one of my two values. I've got half of my compound inequality that I'll need, because eventually when I go to graph this, I'll have two little spots to look at, and we'll just have to shade either in between or to the outside. Second, over on this side, I'm going to do the algebra as well. Subtracting 5, nothing really weird there. And we get that negative x is less than or equal to 2. But, of course, right when we get here, we have to remember that since this is negative, we're going to have to flip the sign. Like, there's a really nice way of showing why that is. It comes from adding x to both sides, but for the most part, you just remember to flip the switch, as Mr. Salazar used to say at Jackman. And so if you just multiply both sides by -1, that's going to give me positive x, -2, and the sign switches because of that negative. We multiplied or divided by a negative, means we got to switch it. And so here are our two pieces. X is less than or equal to 12, or x is greater than or equal to -2. So now looking at these two numbers, clearly the smaller one is -2. So just note that. I know in case you're listening with the sound off. The smaller one's -2, so when we look at a number line, -2 is going to be there, and 12 is going to be over here. You can kind of imagine 0 would be somewhere in the middle. but I don't really worry too much about putting 0 in there, so it's just up to you. But now that we got those two guys, we now need to figure out the shading and the dots. So first, to represent whether these guys in particular would work as solutions, we draw a dot. Because this is less than or equal to, that little equal to thing underneath it means that we're going to have filled in solid closed dots. And that just means that the number actually works. If we plug in 12 over here, for example, we'll have 12 minus 5 is 7, times 3 is 21, minus 4 is 17, and that is less than or equal to 17 because it's equal to it. So for both of these guys, we're going to get a nice closed dot. Next, we have to actually do the shading. Like, is it going to be out here, in here, over there, like somewhere else? Well, what we can do is we can just look at each inequality. Like over here, for example, it says that x is less than or equal to 12. So we'll be shading that way. Those are the smaller numbers. We always shade smaller numbers when x is a smaller number, so we shade towards them. In this case, it says x is greater than or equal to -2, so x is the bigger numbers, so we'll shade this way. What you can see is that when we shade this way, we end up covering everything in the middle. And so our final answer here, our graph solution, would be this guy. As an alternative, I've seen some people do it this way for the graphing. They draw like this thing to represent it. That could work too. That's totally fine. Makes sense to me. I just like the traditional. Shading thing because it's fun to draw those little curls. Like, who doesn't love to do this all the time? I could do it all day. Maybe I'm going to. No, I'll stop. Okay, so here we go. We've solved an absolute value inequality. In this case, we got one that's called a conjunction because it goes towards the middle. And the way we did that was first we got the absolute value alone. We isolated the kind of tricky part or the harder part in the inequality. Then we split up into two inequalities and used the definition of absolute value. Either the inside could be positive, and that could be less than or equal to 7, or the inside could be negative, in which case the negative of it could be less than or equal to 7. And then from there we just solved two inequalities, remembering that we did have to flip the switch along the way. And that gave us our answer, which we shaded correctly. If at this point in the lesson I would ask, are there any questions? But since you can't answer me because you're on the internet, I'm just going to go ahead and say there's one example. Let's go ahead and look at a second one. Okay, welcome back. Well, you probably didn't go anywhere, the video just continues, but for me I took a short break. So anyway, we're back and I want to do a second example of graphing an absolute value inequality, which of course involves solving it. Over on the right side, once again, we did have a couple key facts. I've talked about them before. We have to get the absolute value alone in the inequality, so it's just on one side. And we also have to use the definition of absolute value, or at least we probably should, in order to make sure everything's done right. And then I didn't mention it here, but we should expect to flip the switch. And of course what I mean by that is we have to switch the direction of the inequality. Flip the switch. Don't know what that is. We flip the switch when we have to change the direction of the inequality when we multiply or divide by a negative number on both sides. Let me just write that in there. When divide. Okay, so looking at the second example, I'll try to kind of hit everything. Remember our first one ended up looking like this. It was a conjunction shaded toward the middle with two closed dots. We solved it just fine, no real issues. The second one, not that there's going to be anything different, but throwing a couple little things at you. First, we've got the inequality sign facing a different direction, so we'll have to look at that. And second, there's a fraction in here, so a couple little twists that might throw somebody off if they go to do it. So of course our first step is we need to get the absolute value alone. I can totally do that. So I'm going to subtract 7 from both sides. That's going to give me 2 absolute value of stuff is greater than just greater than 12, and then I'm going to divide by 2. No, I'm not. That's not good form. I should put this in there. I'm just being lazy. That's okay. So when we do that, we'll get as our absolute value inequality, absolute value of 1/3 x plus 5 is greater than 12 divided by 2, which is 6. Excuse me. So at this point, where we go is it's like we've got this first step done. Now we've got to use the definition of absolute value. So at this point we've got two possibilities. Since the absolute value always turns things positive, our first possibility would be that the inside there, 1/3 x plus 5, is just plain old greater than 6. Because, well, the positive thing could be greater than 6. The other possibility could be that this thing on the inside is negative, in which case negative 1/3 x plus 5, in other words changing the sign to make it a positive, could be greater than 6 as well. And those gives us our 1, 2 equations, and this will give us our inequalities, and this will give us our two inequalities that we'll eventually graph up here. So let's go ahead and start working with them. So I'll just do the left one first this time, just because it's pretty straightforward. I'm going to subtract 5 from both sides. It's going to give me 1/3 x is greater than 1, and then of course to get rid of 1/3, we just multiply by the reciprocal on both sides, just 3, and we get that x is greater than 3. We can't go graph it just yet because we don't know how that number is going to relate to this other guy. So instead we just kind of leave it there. We're like, yeah, I got it. Okay, next one, the negative one. We'll just have to do a little bit of distributive property work right there. We'll get negative 1/3 x minus 5 is greater than 6. Notice we haven't flipped the sign yet because we haven't multiplied or divided anything on both sides yet. I should add that on there. It's a good thing to include. And I'll just go like this as though that parenthesis wasn't there. And okay, from here, what can we do? Well, we'll add 5 to both sides. Get negative 1/3 x is greater than 11. And then now here's our step. Here's where we're going to have to flip the switch. We're going to multiply both sides by negative 3. And what that will do is that will give us just 1x, or x on the left side. This side will give us negative 33. And our direction was this way before. We have to flip it because we multiplied by a negative. And there's our second half of the inequality. And see, once again, our second one actually yielded the negative answer. So now here we've got what we need. We've got to graph x greater than 3 and x is less than negative 33. So first, relatively speaking, and again some people put a little 0 there, I don't tend to do that. Negative 33 is smaller, so it goes on the left side, it goes on the right side. We're not worried about scale itself here, just the relative placement of these two numbers. Next are dots. Since it's greater than, that means it's going to be an open dot, saying that that number doesn't actually work in the inequality. Like if we plug in 3 here, we'll end up getting something that was not true because 19 is not greater than 19. So on each of these, an open dot looks just like an open circle. And then next, the shading, we have x is greater than 3, which means we'll shade this way, and x is less than negative 33. So it's smaller numbers which go this way. So in this case we have a disjunction, which could also be graphed like this if you want to, or we can just leave it like that, and we have our inequality graphed. It's all the numbers out here, so numbers like negative 34, negative 150, negative 42,367.921, those all work. Those are all solutions, as well as like 5, 6, 7, and of course 42. Those are all solutions over here. And so there is our final answer. So again, followed the same process, added a little bit to our key fact by reminding you about flipping the switch and when you do it, when you don't. And again, we followed the same process with the absolute value inequality. We got it alone, we got the absolute value alone, we split up into two pieces with the definition, we distributed a negative on one of them, and then we just solved both those inequalities and graphed them according to the rules of graphing inequalities. So over the course of this video, you've seen two different examples. One was a conjunction shaded towards the middle, with fairly tame numbers, and one was a little more exotic, although the answers came out okay. That was a disjunction going to the outside. Hopefully this video has been helpful to you. Hopefully standard number 1 will continue to be a strength for you, or if it hasn't been lately, it will become one, and this will have solved a few of your early standard quiz problems. So anyway, this is Mr. Steele signing off. Bye.